Okay, so number one, is that a parallelogram? Yep. How do you know it's a parallelogram? Okay, good. So if you remember back to your notes from yesterday, it's from the number 3 reason. And what did that one say?
Bisect each other.
Okay, if the diagonals of a quadrilateral bisect each other, you know it's a parallelogram. Good. Okay, number 2, is this one a parallelogram?
Yes.
Yep. How do you know that?
Opposite to
Good. If opposite angles of quadrilateral are congruent, then it's a parallelogram. Good job. Okay, so on this one, we're going to plot these 4 points. A is at 3, 1, 2, 3, 4, 5, 6, 7. B is at 9, 10. C is at 1, 2, 3, 4, 5, 6. And D is at 1, 2, 3, 4, 1, 2, 3. Okay. So we want to know if that is a parallelogram or not. So the way we're going to do it is we're going to check to see if both pair of opposite sides are parallel. So let's start off with this side right here, AD. So what's the slope of that side, AD? Okay, good. So down 4 over 1. What's the slope of this side over here? Down 4 over 1. So are these two sides parallel to each other? Yep. Okay. So this one's parallel to this one. Okay, now let's find the slope of AB. Well, yeah, but it's positive 3 over 6. Yep. Up 3 over 6. And then what's the slope of DC? Same thing, it's got a slope of 3/6. So that tells me that this side is parallel to this side. So both pair of opposite sides are parallel, so that is a parallelogram by definition. All right, so today what we're going to talk about is rectangles. Yes, rectangles. All right. So first of all, a rectangle is a... Well, it is a quadrilateral for sure, but a little bit more specific than quadrilateral. It's a parallelogram. Okay, so a rectangle is a parallelogram. So everything we know that's true of a parallelogram is true of a rectangle. So opposite sides are congruent and opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. All that stuff is true of a rectangle because it's true of a parallelogram. But there are some things that distinguish it that make it a more specific type of parallelogram. So, what comes to your mind? What is like the most important thing to make a rectangle a rectangle? Okay, and that's what most people think of whenever they think of a rectangle. They think it's like got to have 2 longer sides and then 2 shorter sides like that. And I mean, that's what I think of whenever I think of a rectangle, honestly, also. But that's not really what makes it a rectangle. Okay, that's it. It needs 4 90-degree angles. 4 90-degree angles. So 90, 90, 90, 90. Let's just talk about the word rectangle for just a second, okay? So just the word itself, rectangle. So rectangle is obviously made up of 2 parts. What are the 2 parts of the word rectangle? Rect and angle, okay? Now you know what angle means. Let's talk about what rect means. Obviously there's a lot of different ways to define the word rect and ways that are that don't really fit to this spelling of it. But, okay, so within the context of this is, so have you ever heard the word rectify? Like you're rectifying a situation. Somebody heard that word rectify? Okay, so if you're rectifying something, it's like you've done something wrong to somebody, you go, make it up, to make it right with that person. Okay? So that's what the word rect means, is to make right. Okay? So rectangle, the angles are made right.
To make right angle.
Okay? So rectangle, you're making the angles right. So that's what's going on there. Okay, So this is the most important thing to like make it a rectangle. There's one other thing that follows from that is that in a rectangle, the diagonals not only bisect each other, but specifically the diagonals are congruent. Okay? In a rectangle, the diagonals are congruent. So what that means is if you drew this diagonal from here to here, and this diagonal from here to here, and measure those two diagonals in a rectangle, they'll always be the same length. Okay? Now, what also follows from that is that since it's a parallelogram, the diagonals bisect each other, and if the two diagonals are congruent, that means that all of these pieces are going to be congruent to each other. So like if this is 9 feet, this is 9 feet, this will be 9 feet, this will be 9 feet. So again, the two most important things here in a rectangle, well, it's a parallelogram, but the other two things is that it has to have 4 90-degree angles and that the diagonals are congruent. All right, so let's drop down here. It says EFGH is a rectangle. GH is 6, so right here, this is 6 feet. And it says that FH from here to here is 15 feet. And the question is how long, the first one is how long is GJ? So G to J right here. How long is that going to be? I mean, if you think about it, okay, this diagonal is 15, which what we just said, diagonals are congruent. So this diagonal is 15. And then this is going to be that diagonal split in half. So if you take 15, cut it in half, that gives you the length of that, which means that is 7.5, which means they're all 7.5. And that's what all these are. Okay. All right, next one. Number 1 says AE is 36. So from A to E is 36. And then from C to E is 2x minus 4. Okay, since a rectangle is a parallelogram, what do I know about those two pieces right there? They're equal because the diagonals bisect each other. So that makes this piece equal to this piece. So I'm going to set 36 equal to 2x minus 4 and then solve for x. So pretty easy. Add 4 to both sides. 4 equals 2x divided by 2. So x should equal 20. Okay, number 2 says BE equals 6y plus 2. So from B to E, right here to here, is 6y plus 2. And that CE from here to here is 4y plus 6. And since this is a rectangle, what do I know about those two pieces right there? They're congruent to each other. So 6y plus 2 equals 4y plus 6. So y equals 2. And it says to just find y, but I actually want to take it and plug it back in because you're going to be doing some of that on your assignment today, so just to practice real quick. So if y equals 2, how long is BE?
14.
Yeah, because 6 times 2 plus 2 is 14. And if y is 2, how long is CE?
14.
It's 14 also. Number 3 is the same thing basically. So let's go ahead and flip it over. All right. So what we're going to talk about here is, all right, if I have a quadrilateral drawn on a grid, I want to know how can I tell if it's a rectangle or not. And so we're going to go through the steps to figure that out. So first of all, go ahead and plot those 4 points, P, Q, R, and S. Plot those on that grid. Okay, so does that look like a rectangle?
Yes.
Yeah, it looks like one, but just because it looks like it doesn't mean anything. I need to prove that it is. Okay, so we're going to do 2 things in following this up here. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So first of all, I need to know, is it a parallelogram first? And then if it is a parallelogram, if the diagonals are congruent, then it's a rectangle. So we're going to start off by showing that it's a parallelogram. And it's just like what we did yesterday, just like what we did on our warm-up. So I want to tell if this is a parallelogram, and let's do it by the definition. So let's start off here with SP, with this side. So what's the slope of this side SP right here? Okay, so for SP, the slope is 3 over 2. Okay, the side it should be parallel to is RQ. So what's the slope of RQ? Same thing, it's 3 over 2. All right, now let's check the other 2 sides. So PQ, what's the slope of PQ? So it's down 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6. So down 4 over 6. Down 4 over 6. And then the other side it should be parallel to is SR. And so what's the slope of that? Negative 4 over 6. Okay, so are these 2 sides parallel? Are these 2 sides parallel? Is it a parallelogram? Yep. So we've got that. Now, just because it's a parallelogram does not mean it's a rectangle. It means it's a parallelogram. So we have to do one more thing to check it. And I mean, there's other ways we could check it, but we're going to do it like this, seeing if the diagonals are congruent. So the diagonal is like from S to Q and from like P to R. Those are the diagonals. Okay, so is this red line right here, this diagonal, is it the same length as this line right here?
Yes.
Are they the same?
Yes.
Can you just look at it and know that?
No.
Nope. Okay, so we're going to have to figure out for sure if they are or not. Okay, I need to know how long they are. So how long is SQ right here? How long is this line right here, SQ? Can I just like count it, just be like, okay, there's 1, 2, 3, 4, 5. Okay, since it's on an angle, I can't count it like that. So how am I going to find the length of that? Well, I conveniently put that right there for you. We're going to use the distance formula. So what we need to do is find the length of both of these segments. So we're going to start off with SQ, okay? So let's start off with SQ. And I'm going to go ahead and go up here and circle these so we know which ones we're dealing with. Okay, so S and Q up there. All right, so I'm going to go ahead and put my radical symbol here. All right, what is the x2 value? It's going to be this one right here is -7, right? So negative 7 is the x2. Minus what's the x1? 1 squared. Plus, okay, what's the y2 value? 0 minus what's the y1 value? Negative 1. Okay, just go ahead and type that in your calculator. Let's see how long SQ is. What is it? 8.06. All right. So now I need to check that other diagonal, PR. Okay. So let's check PR. So now I'm looking at this one and this one. So what's the x2 value? Negative 1 minus what's the x1? Negative 5 squared. Okay, what's the y2 value? Negative 4 minus what's the y1? 3. All right. So that's going to tell me the length of PR. How long is that? 0.06. So are the diagonals congruent?
Yes.
Yes, they are. So is it a parallelogram? Yep, we showed that. Are the diagonals congruent?
Yep.
So is it a rectangle?
Yep.
Yep. If it's parallelogram and the diagonals are congruent, it's a parallelogram. Now, there's another way we could do this, and that's by checking the slope and seeing that their negative reciprocals to be 90 degrees. But I want to go ahead and do it using distance formula here to find those diagonals. Okay, so what I want you to do now is go ahead and plot those 4 points on that last one. Plot J, K, L, and M. Okay, does that look like a rectangle? It looks off just a little bit, but again, it doesn't matter what it looks like to me, okay? Because my eyes could be playing tricks on me here, and it might really be. So we need to check and see. So let's find the slope real quick. So let's start off with JK. And I'm not just kidding. Let's find the slope of JK. So what's the slope of JK? It's down 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2. So down 8 over 2. Okay, now for ML, the opposite side, what's the slope of that? 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3. So negative 8 halves and negative 8 thirds. Are those two sides parallel to each other? No, so already everything fails right there. It's already out. There's no way it's a rectangle. It's done.